This is a modification of another experiment that you'll be able to see on this series. In the other one, we used 2 aquaria, and we transferred water from aquarium A to B and B to A until we established a condition whereby the levels in the 2 aquaria remained constant. They weren't necessarily equal, but they were constant, i.e. Equilibrium. It was a simulation of equilibrium. This experiment's a little bit different. Same general idea. What's your name?
Melissa.
Melissa?
Stefan.
Stefan. Melissa is going to use this plastic cup to take water out of the tap. And you can use either warm or cold as you wish. And Stefan is going to use the cup I gave him to take water out of the aquarium. And they're both going to do, and you're going to pour the water into here. You're going to pour water into the aquarium.
Okay.
And you're both going to do it at exactly the same time. So you don't take the water out until Melissa starts taking, or you don't pour water in. No,
I don't pour it in.
You don't start taking water out of here until Melissa starts pouring water in. Okay, you ready? Any questions?
No.
And you're going to be the instigator.
All right.
Okay? Let's go.
Okay, come on, hurry up.
Same time, Melissa, same time.
Hurry, hurry.
Same time, wait till he gets it out.
There you go.
What's happening to the level?
It's going down.
Is that because they're being sloppy?
I think so. Clearly one much sloppier than another.
You watch one of these cups with them
And it's not you.
Well, I guess the rest of us can put our, if it were winter, I'd say our hats and coats on and leave Melissa and Stefan here until they finish the experiment. Might take a while. Now, are any one of the 3 of you familiar with what process we're trying to illustrate? Is it equilibrium?
No.
No, it is not. Right. Because in order to establish, in order to consider an equilibrium, a system in equilibrium, it has to be a closed system. You change A to B and B to A, but it's all from inside the system. And what are we doing here? I think we better stop before we end up with water on the floor. Here we're keeping this different water in and out, in and out. There's some chemical connection, but basically it's a biological process, homeostasis. Familiar with homeostasis?
Not too much.
Okay. It's a process, it's a steady state. A steady state rather than equilibrium. The atmosphere continues to be roughly 20% oxygen, 80% nitrogen, even though we take some oxygen out and take some nitrogen out, put some back in. More comes from other sources to maintain the, not equilibrium, but the balance. Okay, you can talk, I hope you can bring this one back to the biology teachers at your school or the junior science teachers and get into some real conversations with the enemies. Not the enemies, with the rest of our staffs. Thank you. Thank you.